folks, in this video we're going to be building a Python API using AWS Amplify. So most resources that you've probably seen if you've done a lot of deep diving into AWS Amplify show a Node.js REST API. So we're going to use a couple different things. So we're going to use the Amplify CLI in order to provision resources. We're going to use AWS Lambda to write our actual function. And then we're going to use DynamoDB to store our data. We're going to build a full CRUD API in order to manipulate our data with all of those actions. The demo that we're going to be building is a Britney Spears song API, which fits my interests pretty well. I'm a big Britney Spears fangirl. I'm going to go ahead and start off with a React app. There's barely going to be any React in this tutorial, so don't worry if you don't know React. I just write a lot of React, and so going to go with that for the front end framework in this tutorial, but again, we'll barely be using it. So I'm going to do npx create react app Britney Spears API. Now I'm going to change into the directory that was created. And I'm going to run Amplify init. This will make my project into an Amplify project. We need to enter a name for the project. I'll go with the default one. A name for the environment. We'll go with dev. I'm going to use VS Code. It'll be a JavaScript app. It's going to use React. Source, build, npm run build, npm run start. If you're doing something different than create React app, you may need to change these things, but it's pretty good at figuring out where you're at and what directories to use. I'm going to use my AWS profile, and that will initialize my project in the cloud, so it'll take a couple seconds from here. So now Amplify has been initialized, and we can add resources to our project. So the first one that I want to add is storage. We're going to use DynamoDB for storage. It's going to be our database that we use, and we'll add and manipulate data within it. So we'll do Amplify add storage. And we're going to go with NoSQL database. Content would be if you want to store like images or static files, this NoSQL database will be DynamoDB. Provide a friendly name for your resource. I will call mine Britney Spears DB. And I will call my table Britney songs. I need to add columns now. So the first one I'm going to create is ID, which is going to be a string. I'm going to use a UUID for this. It'll be randomly generated. I need to add more columns. This one's going to be name. So this will be the name of the song, which will also be a string. I'm going to also add year, which is going to be a number. I'm also going to add link, which will be a link to the actual song. That will be a string as well. And I don't need any more columns now. So it's going to ask me for my partition key. So this is going to be my key that I find items by. So I'm going to go with ID. I do not want to add a sort key. I do not want to add any global secondary indexes right now, no. And no Lambda triggers. Now I'm going to run amplify push-y, and this is actually going to provision the database in the cloud. So Amplify follows this push-pull model, kind of like Git, where you can run push to push any resources to the cloud. Now that we have a database deployed, we want to add an API on top of it. So we're going to run amplify add API. It's going to be a REST API. I'm going to call it Britney Spears API. and I'm going to provide my base path as song. I want to create a new Lambda function. I'll call it Britney Spears API, and I'm going to use Python. So you can choose between different languages here, and I want it to be a Python API. We'll also need to configure some advanced settings in order to provide access to our database. So yes and yes. And I want to give access to storage and create, read, update, and delete. Keep in mind that in a production application, you would want to follow the least privilege principle, where you would give the least amount of access possible to from resource to resource. In this case, it's kind of a demo, so I'll just give it access to everything. I do not want to invoke it on a recurring schedule, and no Lambda layers. If you click yes or type in yes here, it's going to open up your function in your text editor. So I'll do that, and then I'll press enter to continue. I don't want to restrict API access, and I don't want to add another path. I'm again going to run amplify push-y in order to provision that Lambda function in the cloud. Okay, so now our resources are deployed. I'm going to change into the directory of my function. I did have to change my function name just because I had another one with that name already in my Lambda console. So mine is now Britney Spears Song API. Just as a heads up, that naming may be a little bit different for you if you followed the actual instructions. So I'm going to change into that Britney Spears Song API. And then we're going to need to use pipenv. So pipenv is a Python virtual environment and package manager. So I'm going to go ahead and install some Python packages that will be used in my function. So pipenv install AWS WSGI, Boto3, Flask, and Flask cores. So AWS WSGI is a library that's going to handle our routing. It's going to allow us essentially to use Flask routing within Flask and Lambda. It's going to make Flask and Lambda play well together, essentially. Boto3 is the AWS SDK for Python. Then Flask is the web framework we're using. Flask cores is going to allow us to get around cores errors. So let me run that. Okay, so I'm going to open up my code in my text editor. And you can see that a pip file was created and our packages are put in there. There are some other files generated as well. You don't need to worry about them for now, but I'm going to open up this index.py, and this is where my code is going to go. So you can create a new Lambda function for each route that you have. So you could create one function for song. You could create another one for song with the ID to get that one. You could create a new function in order to create a new song, etc. You can also use a web framework within Lambda in order to handle multiple routes within one function. And generally the Lambda DAs, or the serverless developer advocates, they recommend having one function per route. But within Amplify, it can be a little bit clunky to do that just because you'll have to give permission to each function to have access to DynamoDB and all of that. So we are going to, for the sake of this tutorial, use Flask and create multiple routes within this one function, but just know that it is an option to create a new Lambda function for each endpoint. Okay, so I'm going to clear out what's here already. I do not need this. And then at the top of the file, I'm going to import that Flask cores. So from Flask cores, import cores. I'm also going to import some things from Flask. So from Flask, import Flask, JSONify, and request. Then I'm going to create a new Flask instance. So this is going to be my application. And then I'm going to run cores on that app in order to handle cores. Then I'm going to import AWS GI. And AWS Lambda is going to be looking for this handler function, which is pretty much just a function named handler, and it's going to take the event and the context. So the event is going to be the event object, and then context will be the Lambda context. And it's going to return an AWS GI response with the app, the event, and the context. And then from here, it's pretty much writing a normal Flask API. If you've ever used Flask before, it's going to look just like that. If you haven't, it's a Python web framework, and we'll dive into that now. So when we call the song route, it's going to first hit this handler function, and then it's going to turn that into an AWS GI response, and it's going to route to the different functions that we have created for the different routes. I'm going to create a global variable here called base route. So this is the name of the route that I set up initially in my code. So when I did Amplify add API, I needed to specify a base route, and I chose song. So I'm going to create a variable for that here. Now I'm going to create my first route. So if I make a GET request to this base route, which is song, it's going to call this function below this. This is what's called a decorator. So this is a decorator pattern. So this app.route is decorating this list items function. We'll start with a hello world. So I am going to start off with Amplify mock. So I'm going to run Amplify mock function and then the name of my function. So mine is called Britney Spears Song API. Yours is probably Britney Song API. And it's going to use this event.json. It'll install the dependencies from your pip file. And I got an error. So this is errors telling me that my event.json isn't right. That's correct. Right now, if I go to this event.json file, it just has test and event. We're going to modify this. So there are a couple different arguments that Flask is going to look for. So the first one is HTTP method, which we're going to test as get as our first test. Then we have path, which is going to be song to start out with. And then query string parameters, which is going to be just an empty string for now. So whenever you want to test a new route, you can come into this event.json and edit it. So now I'm going to rerun that Amplify mock function, provide my route to the event.json, which is provided for you. And you can see that this time you got a response object. So we got the status code 200, we got some headers, and then we also got our body, which is message hello world. Cool. So now we wanted to make this so that we are actually getting data back and able to manipulate it and all that. So what I'm going to do is go back to this index.py and create a route so that I can create a new song. So I'm going to import Bodo3 and OS. And then I'm also going to import UUID. And this is built into the Python standard library. It's going to allow us to create a UUID, which is going to be a unique identifier for each item. So I'm going to create a new route. This is going to be the same as the base route, but this time instead of the method being get, it's going to be for a post route. So it's for creating a new item. I'll call it create song. Then we're going to say request JSON equals request.getJSON. And then we're going to reference the table name. So I need to add a global variable in order to get my table. So table is going to be another global variable. And I'm going to set it to os.environ.get storage Brittany song storage name. So when we created the database, you may have seen that some environmental variables were created, one of which was this Brittany song storage name, and this is going to be the database table. Now we'll create an item. So the first one's going to be the ID. It's going to be a string, which is what this S is. And we're going to set it to the UUID 4. We're going to cast that to a string too. Then we'll do the name. This will be from the request JSON .get. The year will be string for year as well. And then link. Which will be the link. And then we'll return a JSON that just has a message that says item created. I also need to set up my client, so I referred to this client variable here, but I did not actually ever set that up. So right here, I'm going to say client equals bodo3.client DynamoDB. So this is going to allow me to connect to DynamoDB within Python. So at this point, we'll go ahead and deploy our Lambda code. So I'm going to go amplify push -y. This will deploy our Lambda function. Now, while this is deploying, I'm actually going to go into my React code. So I have my app.js here, and what I'm going to do is in here, I'm going to create a request to my API. So what I'm going to do here is actually first go into my index.js and I'm going to configure Amplify. I need to also install the Amplify libraries, so npm I AWS Amplify. And then in here, I'm going to do import Amplify from AWS Amplify. I'm also going to import config from AWS exports.js. This AWS exports has the links to my resources and all that. Then I'm going to run amplify configure. With that config data from the AWS exports. Okay, now in my app.js, I will clear this out. I'm going to import useEffect from React. And then I'm also going to create a function app. And I'm going to export it. And then I'm also going to return just an empty div. And what I will do here is I will create a function to get my data. So this will be the name of my API and the route. Then I'm going to put this in a useEffect. And I need to import API from AWS Amplify. And I'll go ahead and run this server. Got too many things running. Okay, so what I needed to change was the name of the API I was calling. So I changed mine to Britney Spears song API here. It'll match whatever the name of your folder is under Backend. So yours might be Britney song API, non-camel case. Okay, and so now I get the message hello world. The next thing though that I want to test is to make sure that my post request is working. So I'm going to change this to a post request. And I need to pass some data into there. So I'm going to do body. I'll do toxic. Then I'll link to the YouTube video for it. And I'm getting a request failed with status code 500. So how I debug things like this is I go to the AWS console and go to Lambda, and then I go to monitor and view logs in CloudWatch. You can see the error message here. And it says invalid type for parameter table name, none type. So I probably used the wrong environmental variable. And I named my storage wrong. So in my code, I was referring to environmental variable storage, Britney song storage name. And instead, my database is called Britney Spears DB name instead. So I figured this out by going to the AWS console for Lambda, and then I went to configuration environmental variables and saw storage Britney Spears DB name, which is the actual name of my database variable instead of what I had. So now I will rerun Amplify push. Cool. So now let's test it again that we've deployed. So I'm going to refresh here. My fingers are crossed. Item created. So that's a good sign. Now let's create a route that actually shows all these items in the database. So I'm going to go back to my Python code. And in my list items, instead of doing just JSONify message hello world, I'm going to do JSONify data equals client.scan table name equals table. So this is going to do a scan of the database table and see all the items in it and return them. So we can try Amplify mock for this. So my event says is the HTTP get, path is song, no query parameters. Now I'm going to go ahead and push this. And then in here, we can change back to doing the API.get request. So I'm going to comment this out in case I need it in the future. I'll change this back to get. Okay, so now our changes have deployed. So I'm going to go back into the console here, and you can see that I got my data back. So I have my items, and the only item that I have right now is Toxic from 2003. It has an ID and then the link to the YouTube. So using this pattern, we can keep creating routes. So I'm going to go back into my Python code. And I'm going to create a couple more routes. So the first one I'm going to create is get one song. So right now we have the route for listing items. I'm going to change this to list songs. So we have a route to get all of the songs back, but we want also a route to get one song back. So we'll do an app.route base route plus the song ID, and putting it in carets like that will tell Flask that it's a URL parameter. And then we'll do the request method get. Or I'll rename item to song. So what I'm doing is I am requesting the database to get one item from it using my table name, and then I need to use my key, which will be my ID. So that's my route to get one song back. Now I'll also create a delete route. So I'll do the same thing that I did above, where I have my base route and then add the song ID to it. This one, the request method will need to be delete. So we'll do song ID client.delete item, table name equals table, key equals ID string song ID, and then we'll return JSONify message equals song deleted. So now we're almost at full CRUD. So we have a delete route here, we have a get route here, and then we need to have just an edit route. And this one, I'm not gonna lie, is a little bit clunky. So I'm gonna paste it in and then walk you through it. So the route is going to be, again, to the base route, and then take the song ID. It's going to update the song. So we'll do client.update item, and it will be table name is set to the table. So this follows the pattern of all the others. The key is, again, the ID, which again follows the same pattern. And then we have an update expression. So this looks a little bit like a SQL update almost. So set name to name, year to year, link to link. And then the expression attribute names, this is plugging the actual column name into all of these left-hand variables. So hashtag name is set to name, hashtag year set to year, etc. And then the values. So name, year, and link. This is going to update the song name, year, and link. It's going to set those to the values from the request. And then it says item updated when that's done. You could also change this to what we had above here. So we set the request to get JSON and then request JSON.get, but either way works. So now we're going to run amplify push-y in order to deploy all this. Now I'm going to first change my React code in order to get just one item. So I'm going to go back to this React code here, song, like this. So with the ID of the one item that's in my database. So now we're deployed, and I'm going to refresh here. And you can see that when I do the get with the one item, you can see that the item comes back right there. And instead of it being items, it's just the one item. So now we've tested 3 of our routes: create, list songs, and get song. Now, should we try to delete our song? I think we should try to delete it. Okay, so api.del. This will set a delete request instead. We got 500. Oh no. So I'm going to go back to CloudWatch, see my error here. So now if I look at my logs, it says type error, unhashable type dict. Okay, let's look at my code. Song ID, song ID, song ID. Okay, so I put a comma instead of a colon right there, which was my issue. So I'll go ahead and push that change there. So silly. And now I need to also try my update. So I'm going to change this to put. And I'll change this to toxicity instead of toxic. And I'm getting an error for that one too. Fun. Let's see what I did. I'll refresh my logs. So in here, I called it song name instead of name. So I'm going to change this to song name for now. I probably want to change that to be consistent on my backend. And now we can see that item was updated. And then if I change this to get you can see that my item updated to toxicity. So my update is working now. And it looks like my delete deployed as well. So let's try that again. So I will delete this object here and do del. And now you can see I have no items left. So I successfully have full CRUD. You got to see me debug using both Amplify Mock and the CloudWatch management console. We also made a full REST API with Python and Flask within Amplify, so a little bit different and fun there. Thank you so much for watching. If you want more tutorials like this, please leave a comment. Subscribe to my channel to be notified about new videos like this, and I'll see you next time.